So hydrocarbons, the basic organic compound, the compounds which are formed by carbon and hydrogen only, these are called as basic organic compounds, and they are also called as hydrocarbons. Hydrogen and carbon, combination of the two. When carbon atom shares one electron each with 4 hydrogen atom and forms 4 CH bonds, a methane molecule is formed. Now in most of the books as well as teachers will indicate methane molecule like this. Carbon having 4 valencies and hydrogen is attached to it. But in reality, this is not so. So try to understand the problems which are going to get whenever we are going to form the compounds. Are you able to see this?
Yes, sir.
Yes.
Yes, sir.
So actually, this is the way how the methane molecule look like. These are the ways where the particular electrons are. And the hydrogen shares it and forms something like this. So this is the way how it is. It is not a planar structure as we call it as. This angle between any two atoms or bonds is 109 degrees everywhere. This is what is called as tetrahedral structure. I hope you are able to see it properly now.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So this particular is a ball and stick model. These are the hydrogens. And this is the covalent bond, that is by sharing electron, one of hydrogen and one of carbon, and this particular bond is formed. So that is why it is said that there are 4 covalent bonds.
Excuse me, sir.
Yes, please.
Sir, every angle is 109 degree.
Yes.
So means it is already fixed.
Yeah, it is already fixed. Whenever carbon is going to have 4 valencies and going to attach itself with hydrogen, the bond angle will be 109. And this is calculated by X-ray diffraction pattern. You may just note down this name. Whenever you will learn it, you will come to either remember it if your memory is good.
सर डायमंड में भी ऐसे स्ट्रक्चर बनता है ना?
हाँ, diamond is several many such, but in diamond there is no hydrogen. Carbon is attached to carbon.
Yes.
So when it is diamond, at that time this is what will happen. A carbon will be getting attached to another carbon. And
Sir,
over here. Yes. Yes, please.
सर जो व्हाइट कलर का आप अटैच कर रहे हैं वो क्या है?
वो बॉन्ड है. So this is the way how the particular diamond is formed. Now it will be over here, and then it will be combined. A very complex structure. We cannot understand the meaning of the structures by drawing the lines and the dots. Anyway, fine. So I will go back again. So this is what is called as dot structure. Over here, every dot represents electron. So you may say that these are the electrons of carbon, which are in outermost orbit. Obviously, in innermost orbit also there will be two dots. And these are the electrons which are shared by the hydrogen. But here we always feel that the angle between the bond is 90 degrees because it appears to be in a plane. So this particular is additionally provided. And now let me hope that your concept about the tetrahedral structure of carbon is clear. Now I will proceed further. Over here we are saying that the covalent bond is formed. So whenever covalent bond is formed,
Sir, please show the previous slide.
Beta, you will have to hurry a bit because I want to show the experiments as well as I want to complete the topic. So if at all such particular queries are there, be ready that I may exceed 8:30 today.
Done, sir.
Okay, good. So the covalent compounds, they always have low melting point as well as low boiling point. They are very rigid in structure. Generally, they are insoluble in water. And they are readily soluble in organic solvents. We are talking about covalent compounds of carbon. They are poor conductors because they don't have free electrons. Poor conductors of heat as well as electricity because the structure is very rigid. So heat is not transferred so easily, as well as for electricity, there is no free electron. Clear with this?
Yes, sir.
Yes, sir.
So don't just write down
No,
the
sir.
properties, try to understand the reason behind it.
Sir, this is the first slide of today's lecture, na?
No, this is third slide, second slide, I suppose.
Sir, can you please show the previous slide?
You can see it afterwards, beta. Recording is going on, so you can see that afterwards. It only says that the compounds which are formed by carbon and hydrogen, they are called as carbohydrates or hydrocarbons.
Sir, just for a minute, I'll take a snapshot.
Snapshot is not the solution, beta.
Yeah, sir, I'll write that this
Yeah.
point,
Okay.
last point
Okay.
afterwards.
Okay, no problem. Just take the slide, screenshot.
Done, sir, or take next.
Sure. So whether everyone is done with this, note it down.
Yes.
Yes, sir, completed.
Now there are some few types of hydrocarbons. This is again very interesting thing. The hydrocarbons having only one single bond. Single bond means one electron of hydrogen getting attached to one electron of carbon. Such particular is called as saturated hydrocarbons. Nothing else can be added to it now. For example, C2H6, which is called as ethane. ANE is the particular important part. ANE stands for saturated hydrocarbons. So obviously this C2H6 will be represented like this. And if I want to show it by the figure, then the figure is generally shown in this way. Carbon is attached to one carbon. Now there are three places vacant. So the hydrogen will be over there. And again, three places will be vacant. So hydrogen will be there. So this is the way how the ethane molecule is shown.
सर वो ओनली सिंगल बॉन्ड्स का यहाँ पे एक ही साइड का आइटम है क्या, क्योंकि हर जगह तो वो चारों बॉन्ड पे हाइड्रोजन जा रहा है.
कार्बन एटम के इसमें क्या बोल रहे हैं अपन बेटा? We are not talking about anything else. Between the two carbons, there must be a single bond. Means there will be sharing.
सर सिर्फ कार्बन और कार्बन में ही क्या?
हाँ, कार्बन का ये क्या डेफिनेशन वही बोल रहे हैं ना बेटा, जो डेफिनेशन बोलेगी वही अपने को समझना पड़ेगा. क्या बोला है डेफिनेशन ने? सिंगल बॉन्ड बिटवीन कार्बन एटम्स. तो बाकी एटम को मुझे देखना ही नहीं है. और बाकी एटम हाइड्रोजन ही रहेगी. Now this particular, when there are three carbon, then it is called as prop. So prop N. It will look like this. Now, if you see this particular figure very carefully and your observation is good, you can see that this hydrogen is over here and these hydrogens are diverted like this. They are away from this.
सर
Yes.
उसमें कार्बन को 3 है हाइड्रोजन और वो सेकंड इसमें 2 ही है, क्यों?
अरे, उसका एक इलेक्ट्रॉन इसके लिए नहीं यूज हुआ क्या, कार्बन के लिए? ये देखो, I will just drag this particular picture for my understanding. You can just put one particular tap on mobile and you will get the particular thing very easily. So this is the way how the things are. This is carbon and this is carbon. Now there is a single bond between two carbon atoms. Now when there is a single bond between these two carbon atoms, over here there will be 3 hydrogen, and for this also there will be 3 hydrogen. But now for propane, I am not going to have only 2 carbon atoms, I will be having 3 carbon atoms. So the structure look like this. Now please tell me that how many hydrogen will be available over here?
2.
Only
2 sir.
2.
Yeah.
सर वो इस बीच वाले के साथ तो 2 बॉन्ड बना रहे ना हाइड्रोजन, तो उसको एक ही
कहाँ
कैसे
दो
count
बने,
कर रहे
कहाँ दो बने बॉन्ड्स? बॉन्ड एक ही,
हैं? अच्छा,
दोनों कार्बन ने शेयर किया इलेक्ट्रॉन वहां पर।
सर फिर वो डबल बॉन्ड कब बोलेंगे उसको?
डबल बॉन्ड जब आएगा तब बोलेंगे, अभी तो डबल बॉन्ड है ही नहीं ना वहां पर। मैं बताऊंगा ना डबल बॉन्ड कब बोलेगे तो।
सर इसको फिर एक ही बॉन्ड बोलते हैं।
हाँ, so this is what is propane.
सर इसमें भी 109 का ही
No,
बॉन्ड
no,
होता
no, no. Over here the angle differs.
है। सर क्या रहता है?
मुझे याद नहीं है अभी, मतलब मालूम है मगर याद नहीं किया हुआ मैंने। लगे तो एंगल्स में बोल दूंगा सब इसके। Similarly, if there are instead of 3 carbon atoms, 4 carbon atoms are there, then it is called as but. So but will all the time and every time indicate 4 carbon. And because it is having single bond, so it will be ANE. So this is how it will look like. Now you can imagine this quite easily. There will be one more carbon over here. And please note that it will go like this.
सर वो बीच वाले को अटैच नहीं होता क्या दूसरा कार्बन?
कुछ भी करो ना तुम, कैसे भी किया तो भी बीच वाले को अगर किया तो ये नहीं रहेगा ना वैसा। बीच वाले को हुआ तो वो आइसो बोला जाता है उसे, आइसोब्यूटेन। There is a structure like that. We are talking about the straight chain. Very good. You have thought wonderfully over there. Now try to think about if suppose there are 5 carbon atoms, then how many hydrogen will be there?
12.
12. Very good.
There's always an addition of 2.
Yes. in double. So if I'm having Cn, then H will be twice N plus 2. And this will be called as alkane. Please note down the name over there, alkane, A-L-K-A-N-E. ALK is the general name for hydrocarbons.
Sir, can you please repeat the name?
ALKNE. I suggest don't take the screenshots, write down the things. I'm hearing the sounds of buttons.
So complete writing.
Now some hydrocarbons have multiple bonds between the two carbon atoms. A multiple bond can be double bond or triple bond. Now it is extremely difficult to understand this topic. I won't be able to explain each and every details, but just try to understand the difficulties at least. Now this particular is ethane. We want to have the double bond over there. That means this electron of carbon and this electron of carbon will be contributing with each other. This is for my understanding. This and this are going to share with each other. It is not an easy job, na? Because they are moving away from it. How they can be over here? So carbon molecule changes its structure. It is called as hybridization. This particular at present is sp3. It turns into sp2. And then the compound which is created is something like this. For this particular, the carbon is not the one which we have seen previously. It is slightly different than the previous. This is how the carbon changes itself. कुणाचा तरी माईक मधून आवाज येतोय, माईक बंद करा सगळ्यांनी. I will remove that student. घाटोळ, यश घाटोळ, तुमचा माईक चालू आहे आणि म्युझिक ऐकायची लाज वाटायला पाहिजे तुम्हाला. If you are so insincere, better leave the class or I will make you leave. Still, you have not put your mic off. So the way how this particular forms the bonds is like this. Now here this bond is not called as covalent bond. This time the double bond is called as sigma bond. Its length is more than the single bond. And the hydrogens are attached in this way. So this is how the structure is. We only show this part. And we call this as double bond.
सर वो बीच वाला भी बॉन्ड है क्या, व्हाइट वाला की
Yes,
लाल
this
वाला bond?
particular white is a sigma bond and these are called as pi bond.
सर तो ये तीन हो गए ना?
No, this particular is called as one single bond. It is sharing.
So that one circle is one bond.
Yeah, something like that you may call it as. It is not a circle, but anyway, one may, for understanding purpose, one may call it in that way. And I have said already that this is not that easy to understand. We will need lot many things for this. And at present, we won't be in position to understand everything. For hybridization, we will need the particular Bohr's theory is not sufficient. We will need Schrodinger's theory. Not many different things. So better, we won't be going into those details. But the way how it is represented, that we should know.
Sir?
Yes, please.
In the diagram you've shown, there's two of the red bonds. So one of the red bonds would count as one.
Please speak little loudly. I'm not able to hear you, Anika.
Sir, it's like in the diagram you've shown, one red bond would count as one, or like if both of them are there, it would count.
No, it is not one bond. This particular is called as pi bond. This also is pi bond. Pi bonds are always in pair. This constitutes one bond.
Okay.
And this is what is sigma bond. Now it is not covalent bond. It is not due to sharing. It is due to overlap.
Okay.
So though while indicating, it is indicated like this. Carbon having double bond, carbon, and then there will be two hydrogens. This is the way of indication. If the book is taking more care, then it may indicate it like this. Again, this angle is not 109 now. And this bond length is more than the covalent bond. Sigma bond is weaker than the covalent bond.
सर ये डबल बॉन्ड में कमजोर क्यों होता है कोवेलेंट से, इसमें दो बन रहे तो भी?
Or there the particular electrons are more near, so negative repels. More electrons are there. Previously only one electron was there. Now there are two. So there will be repulsion among them.
Sir, this is only for double bond, right?
This is only for double bond, as well as in triple bond also the worst thing will happen. Over there the three electrons will be shared.
So it's getting confused.
Sharing, it is called as overlap.
Okay.
Excuse me, sir.
Please.
Sir, can a single bond be formed from a double bond?
Yeah, obviously when your double bond breaks, it will form a single bond.
So, sir, therefore, a double bond or a triple bond is called as unsaturated.
Yeah, it is called as unsaturated.
Okay.
So this is how the structure which I have shown you right now. As you can see that this is what is called as pi bond. This is clear with this, very clear.
Sir, is it called pi bond because it looks circular?
No, not because of that. No such shapes are there, beta. This model makes it circular. Na?
Oh, okay.
Ah. Fine. Then if there are two double bonds, then it is called as ethene. This is ethane. So the general name will be alkane. And this will be alkyne. This is the way how that two double bonds are represented. But in reality, it is like this. And for this, carbon changes itself in this way. So there are these two are the sigma bonds for sigma bonds, and this is what will be forming pi bonds. Here the final structure is.
Sir, this is of which one, sir?
We are talking about the triple bond, two double bonds. So this is one sigma bond over here. This one, this is sigma bond. And this particular is a lateral overlap. That's why this is pi bond, this is pi bond. This is one single bond.
सर वो वन सिंगल बॉन्ड में एक ही इलेक्ट्रॉन रहेगा क्या एक कार्बन का?
हाँ, एक कार्बन का एक ही रहेगा।
सर वो फिर कौन से साइड रहेगा? दोनों तरफ से निकल रहा तो?
नहीं, ये ऐसा दोनों तरफ से ऐसा रहेगा नहीं, ये बॉन्ड है बेटा, ये इलेक्ट्रॉन नहीं है यहाँ पर। ये हम आगे का देख रहे हैं, ये इलेक्ट्रॉन वाला जो सिस्टम है वो तो यहाँ पर दिख रहा है अपने को स्क्रीन पे, जो खत्म हो गई झंझट। ये तीन इलेक्ट्रॉन इसने शेयर किए, तीन इलेक्ट्रॉन इसने शेयर किए, और ये यहाँ पर हाइड्रोजन के साथ में क्रॉस वाले यानी कार्बन के हो गए, डॉट वाले यानी हाइड्रोजन के हो गए, खत्म हो गया। मगर इससे हमें ठीक से समझने के बजाय हमारा गलत इंप्रेशन हो जाता है कुछ तो भी। अब मुझे बता, इलेक्ट्रॉन घूमे बगैर रह सकते क्या वहां पर?
नहीं सर।
इलेक्ट्रॉन को तो न्यूक्लियस के इर्द गिर्द घूमना ही पड़ेगा। हाँ, अब ये तीन इलेक्ट्रॉन कैसे घूमेंगे बता मेरे को?
नहीं घूम सकते सर।
तो ये हमको मूर्ख बनाना हो गया ना। ये फिगर हमको मूर्ख बना रही है। हमने झगड़ा करने को ना टीचर के साथ में।
हाँ सर।
हाँ, तो फिर असल में क्या है? तो असल में ये है, कार्बन ने खुद को चेंज कर लिया थोड़ा सा। उसने उसके जो इलेक्ट्रॉन क्लाउड्स है, जो वहां पर इलेक्ट्रॉन दिख रहा है, वो ऑर्बिट को चेंज कर लिया। इस चीज को बोला जाता है पी ऑर्बिट। ये ऐसे रहता है, और ये जो है ये डंबल शेप में ऐसा रहता है। ये ओवरलैप हो गया, यानी हो गया पाई बॉन्ड, ये दूसरा पाई बॉन्ड, और ये सिग्मा बॉन्ड। ऐसे कुल मिलाकर तीन बॉन्ड हो गए, दो पाई बॉन्ड और एक सिग्मा बॉन्ड। ऐसे ये हो गए तीन बॉन्ड्स। तो सर सिग्मा बॉन्ड में शेयरिंग ऑफ इलेक्ट्रॉन है क्या? नहीं, शेयरिंग ऑफ इलेक्ट्रॉन नहीं है, वहां पर ओवरलैप है ऑर्बिट का।
सर तो इसमें इलेक्ट्रॉन्स फ्री घूम सकते क्या?
हाँ, इसमें तो घूम सकते ना। दिस पर्टिकुलर विल बी इन दिस वे, इट्स अ डंबल शेप ओवर हियर।
अच्छा,
वो इलेक्ट्रॉन यहां पर घूम सकता है।
और सिग्मा बॉन्ड का सर वो ऊपर नीचे हो गया क्या?
This particular is over here. It is direct overlap. यानी अगर ये मुझे बताना है तो मैं कोशिश करता हूं बताने की. You see, this particular is the sigma bond. Over here, this overlap is there. This indicates sigma bond. और ये जो है so this particular is the pi bond. अब जैसे ये यहां पर हो गया वैसे यहां पर ये देखकर मुझे तो याद आ रहा है सेमी सर्कुलर कैनाल बायोलॉजी में ईयर का स्ट्रक्चर. So this particular is the way how electron is moving. This is the hybridization which carbon brings in it. Three-dimensional figure. यहां पर हाइड्रोजन अटैच होगा, यहां पर दूसरा कार्बन अटैच होगा और ये बॉन्ड्स ओवरलैप होकर वहां पे पाई बॉन्ड्स बनेंगे. और ये अगर समझ में नहीं आया तो कुछ बहुत टेंशन लेने वाली बात नहीं है, ठीक है. But I tried to explain it. Think about it. Okay. Now something which is quite simple, easy and simple. We want to see the reactions of carbon and carbon compounds. First of all, very simple thing. So obviously I'm having water in this. This is obviously edible oil and this is kerosene. Here I am having the carbon powder. Now I will be adding this particular carbon to these test tubes one by one. I hope that you are able to see the things over there. I will remove all other things from this table. Kerosene is having its typical smell. I don't know how many of you have seen kerosene. Earlier means basically it is colorless, but now it is added with color just for not allowing it to be used by other fellows for other purposes. So I will just keep my thumb over here and I will try to stir it. Now this particular has turned out to be black. But this is the suspension will be seen over here very clearly. Same will be true with this. Now you can see that the carbon particles have settled down and now they are hanging over here. So it is not soluble. It is spreading. So again over here it is spreading, and if I keep this for some amount of time, it will settle and the clear structure will be seen. Because it is very fine powder, it is spreading very fantastically and the color appears to turn, but it is the particles which are suspended over there.
Excuse me, sir.
Yes, please.
Sir, why are the liquid changing to another color?
It is because these particles are spreading over there. The dots are seen over there.
Okay, sir.
We will keep it over here again. Just see, now you can see it clearly.
So it looks more like a suspension.
It is suspension. Precisely, it is suspension.
Oh.
Yes, sir. Suspense.
Yeah. इथे लागत असेल तर इथे बघा. Can you get any difference over here in viewing it?
So it's opaque.
We will keep it aside so that it will become transparent in the upper part and it will remain like this in the lower part afterwards. Anyway, fine. So we will move further. नाही काही गरज नाही. When carbon is burned, it reacts with oxygen to produce carbon dioxide. In this gas is allowed to pass over the moist blue litmus. It turns in red because first carbon dioxide reacts with water. It forms something which is called as carbonic acid. And every acid turns blue litmus. Are you able to read this?
Yes, sir. Blue
Yes, sir.
litmus.
Blue litmus.
Yes, sir.
Whether it is inverted for you or is it okay?
So it's okay, sir.
It is okay.
Fine. The litmus paper seems like this, and we will definitely do the experiment, but not by burning the carbon because it will make everything dirty and it is not so easy to burn carbon. I do have carbon pieces with me, but I'm not going to do that experiment. One reason is it will take much extra time and it won't be so easy. If at all I do that experiment, virtually it will look like this. I will need one burner. I can use candle for that, but then I will have to hold the carbon piece for long amount in front of candle. The burner gives more bright flame. So let me hold the carbon or coal on the top of that particular burner. Obviously fumes will come. These fumes are nothing but made up of carbon dioxide. On what basis you are saying so, sir? Well, I will take the litmus paper. It's a moist blue litmus paper. And now within very few movements, it will turn red. And this indicates that it is reacting with H2CO3, known as carbonic acid. Now this part is not given in the textbook, but this should be known to all of us. So this experiment is a virtual experiment for you. But whenever we will have carbon dioxide gas, at that time we will try to indicate how the litmus turns red over there. Everyone finished?
No, sir.
No, sir.
Yeah. I will wait whenever I will hear no, sir. मॅडम आगपीटी आहे का इथे? आगपीटी?
सर एक्सक्यूज मी सर.
यस.
सर वो कार्बन जब कोई बॉन्ड बनाता है तो उसके इलेक्ट्रॉन्स उसी के अराउंड घूमते कि वो जिसके साथ बनाता है उसके साथ भी वो घूमने लगते हैं?
ये ऐसा घूमने वाली बात ही नहीं होती,
रिवॉल्व
बन जाता है.
अच्छा.
इसके लिए ऑर्बिटल हमें समझना चाहिए, तभी हमें बॉन्ड ठीक से समझेगा. मगर ऑर्बिटल का कंसेप्ट हमें अभी नहीं समझेगा.
ओके सर.
मगर हमें इतना समझना चाहिए कि जो हमें बताया जा रहा है वो गलत है. मैं इतना ही चाहता हूं.
सर तो वो सिर्फ अपना ऑर्बिट में करेगा कि H2 के साथ रिवॉल्व कर रहा है तो H के हाइड्रोजन के ऑर्बिट में भी रिवॉल्व करने लगेगा?
हाँ, अब क्या होगा ये देख, मैं आसान तरीके से समझाता हूं यहां पर. सीधी सी एग्जांपल लेते हैं हम, हाइड्रोजन और हाइड्रोजन. अब ये हाइड्रोजन का इलेक्ट्रॉन जो है वो ऐसा घूम रहा है.
यस सर.
और ये हाइड्रोजन का जो इलेक्ट्रॉन है वो ऐसा घूम रहा है.
यस सर.
अब जब ये इलेक्ट्रॉन शेयर करेंगे आपस में, उस वक्त ये इस तरह का घूमना बंद हो जाएगा. तो फिर वो इलेक्ट्रॉन कहां जाएंगे सर? वो ऐसे डोनट शेप में घूमेगा. दिस इज व्हाट इज द हाइब्रिडाइजेशन. So this is the way how the electrons will rotate. This is
सर इसमें कार्बन कहाँ पे?
कार्बन नहीं रे, मैं एग्जांपल हाइड्रोजन का दे रहा हूं ना बेटा. वो ऑर्बिट यहां पर सर्कुलर रहा ही नहीं, वो डोनट शेप का बन गया, सिंगदाना जैसा रहता है वैसा.
हाँ सर.
अब ये कंसेप्ट हमें अभी नहीं समझ सकता, क्योंकि इसके लिए हमको इलेक्ट्रॉन क्लाउड पता चाहिए, श्रोडिंगर इक्वेशन चाहिए, ऑर्बिटल नाम की चीज समझने को होना. ये अभी नहीं समझेगा, उतनी हमारी मैच्योरिटी नहीं है. उस कारण ये बोलने के बजाय मैं इतना ही बोलूंगा कि भैया अगर मुझे ये बता रहा कि ये हाइड्रोजन है, ये हाइड्रोजन है, ये इसका इलेक्ट्रॉन और ये इसका इलेक्ट्रॉन, तो फिर ये घूमते टाइम कैसे घूमेंगे? इसके ऊपर मेरा आपके साथ में झगड़ा हो सकता है. तो ये ऐसा नहीं है, बस यहां तक ही मुझे चाहिए.
सर वो ऑर्बिट बैलेंस में दोनों का इलेक्ट्रॉन्स काउंट करते हैं क्या, जो इसके साथ शेयर कर रहे हैं?
हाँ,
वो दोनों के लिए काउंट करते हैं क्या कि सिर्फ एक ही के लिए काउंट करते
दोनों शेयर करेंगे ना वहां पर, यानी फिर दोनों का हो गया वो।
हैं? सर वो मतलब सिर्फ शेल भर जाना चाहिए, ये मीनिंग है ना, शेल कंप्लीट हो जाना चाहिए 8
शेल नाम की चीज ही गलत है,
शेल।
ऑर्बिटल नाम की चीज सही है।
सर तो केक शेल लिखा क्यों रहता है फिर?
ये क्योंकि हम बोर का ऑर्बिट पढ़ रहे हैं वहां पर। अब मेरे को अगर पहली कक्षा में बोला कि नंबर्स कैसे रहते हैं, तो 1 2 3 4 रहते हैं।
यस।
अब पहली कक्षा में मुझे फ्रैक्शंस बताए जाते क्या?
नहीं सर।
नहीं बताए जाते, क्योंकि तब मेरे को नहीं समझेगा वो। फिर बाद में मुझे बताया जाता है कि भाई तूने एक चीज ली, उसके 3 हिस्से किए और उसमें का एक हिस्सा ले रहा है, तो वो हो जाएगा 1/3। ये मुझे जब फ्रैक्शन पढ़ाया जाता है तब आएगा वहां पे।
ओके सर।
राइट।
थैंक यू सर बताने।
चलो आगे चलते हैं।
Yes, sir.
Now when carbon dioxide reacts with lime water, lime water बनाने का तरीका कुछ इस तरह से है। This is what is lime water. I have kept the lime over here, added water, then I allowed it to settle down, and this clear thing is seen at the top. There is no white color in it. Actually, I should have transferred it in front of you, but believe me, I have transferred the same water in this, and this also is very clear at present. Now I'm going to use this straw. The straw is clean straw. It's having no color with it. And I'm going to blow my exhaled thing. So obviously it contains carbon dioxide. Please look at this particular clear color once. My shirt whiteness shouldn't be there. And you can see some suspension particles over there. It has turned very clearly white. I can make it still little more white by adding little more carbon dioxide. Now it is doubtlessly white. And if you are very near, you can see some particles which are moving over there.
Sir, it looks like diluted milk.
Yeah, it is like diluted milk. But milk is not showing its particle. Here the particles can be seen. Whenever you will do it at home, you can do it very clearly. सर वो कैल्शियम कार्बोनेट CaOH2 कहाँ से लाना? तो वो लाने की जरूरत नहीं है। पान पट्टी पर जो चूना मिलता है, वो चूना भी भिगो दिया तो भी ऐसा मिलता है। So that particular should be soaked. Clear water must be taken. Blow the thing and you can see the calcium carbonate crystals over there, suspended particles. Everyone should try this at home. Show it to your other friends, your family members. That will make the subject more and more clear. तो रिएक्शन जो है वो कुछ इस तरह से है. लाइम वाटर is actually calcium hydroxide का solution. So calcium hydroxide is having its chemical name as CaOH twice. Whenever it reacts with carbon dioxide, it generates CaCO3. It's a solid and water. Now something which is not given in your book, and it will take nearly about 10 minutes to perform the experiment. But if suppose I keep on blowing over here, it's a long process. But what happens is this suspended calcium carbonate crystals, they again react with carbon dioxide, and water is already over there. And then it generates something which is called as calcium bicarbonate. And this calcium bicarbonate is soluble in water. And that's why it will turn out to be again totally transparent. But this will need some patience, and we cannot waste our time in this. What I can do is I can have a virtual experiment over there. So this is my glass, which is filled by lime water. Then I will introduce a straw, which is in mouth of one of the student. The student is going to blow the air through this, so bubbles will come. Anyway, fine. And after some time, the particular lime water will become milky. Okay. He is blowing very slowly. You should hurry a little bit. Such a slow blowing is not appreciated.
One bubble at a time.
One bubble at a time. People will get bored due to this. Anyway, so now the particular turbidity has increased over there. Anyway, fine. So let me hope that you have concluded properly. Now carbon dioxide, gas which is going to decide our fate, because in greenhouse effect, carbon dioxide is one of the playing major role. So its molecular formula is CO2. Mass obviously is 2 oxygens and 1 carbon. Make the calculations and you will get it as 44. Melting point turns out as minus 56.6 degrees centigrade whenever it is heated when it is solid in state. The occurrence of carbon dioxide is obviously in air in the free state, which is about 0.03% all over the atmosphere. Right now you have seen whenever I was exhaling the air, it contains about 4% of carbon dioxide. But it is only related with the exhaled air, not the atmospheric air. Carbon dioxide is also present as a salt in chalk and Shahabad tiles, marbles, limestone. All these particular, they are containing the carbon dioxide present. Carbon dioxide is given out in a combustion of wood and the fossil fuel coal. Actually, every fossil fuel while burning will be giving carbon dioxide. So these are the occurrences of carbon dioxide. Everyone done?
1 second, sir.
Sure.
Please wait.
सर ये कार्बन डाइऑक्साइड तो हर चीज जलाने से निकलता है, तो सब में बोल सकते हैं कि कार्बन डाइऑक्साइड प्रेजेंट है।
फिर से बोल, क्या बोला?
सर वो कार्बन डाइऑक्साइड कुछ भी ज्यादातर चीजें जलाने से मिलता है ना, अगर हम इंसान को भी जलाते हैं तो उसमें भी कार्बन ही निकलता है, तो बोल सकते हैं कि हर चीज में ज्यादातर में कार्बन प्रेजेंट है।
जहां वो तो कार्बन जब शुरू किया तभी मैंने बोला बेटा।
नहीं हाँ सर कार्बन डाइऑक्साइड भी बोल सकते हैं कि हर जगह प्रेजेंट है।
जहां जहां कार्बन प्रेजेंट है उसको अगर तुम जलाओगे तो क्या मिलेगा आपको?
ऑक्साइड्स, कार्बन ऑक्साइड।
फिर
सर
वो इंसान को जलाओ, तुम पेड़ को जलाओ, तुम कोयलों को जलाओ, तुम पेट्रोल को जलाओ, तुम मोमबत्ती जलाओ, हर जगह जलाने के बाद में अगर वहां पर कार्बन है, डाइऑक्साइड निकालना ही है। अब मोमबत्ती में जो मोम करके जो रहता है, कैंडल वॉट एवर वी कॉल एज वैक्स, वैक्स इज नथिंग एल्स बट हाइड्रोकार्बन। Naturally, honeybees create this. Now you can see that particular thing, what I was saying earlier. This is water and we are having carbon in it. Lower part is clearly transparent, finely transparent, and the upper part is completely black.
Carbon is lighter than water in this proportion.
Carbon particles are lighter than water. Same is over here. Because it is oil, it has been settled at the down part and the upper part of the oil is clear.
सर वो ऑयल के एकदम नीचे का भी काला काला लग रहा है।
हाँ, तो वहां पर कार्बन पार्टिकल्स है, वो और थोड़ा देर दिया मैंने तो वो पूरी तरह से सेटल हो जाएगी, क्योंकि वो सस्पेंडेड पार्टिकल है, वो मिक्स नहीं हुए उसके साथ में।
फिर ऑयल से भारी है कार्बन ना?
हाँ,
ऑयल से भारी है कार्बन यानी।
यस, कार्बन इज हैविंग मोर डेंसिटी देन ऑयल। साइंस के स्टूडेंट होने के बाद में हमने भारी और हल्का ये शब्द यूज करने के बजाय लो डेंसिटी एंड हाई डेंसिटी ये यूज करना चाहिए।
ओके सर।
So let me hope that everyone completed.
Yes, sir.
Yes, sir.
So we will see this particular how carbon dioxide is created. Now, because I want to do some few experiments, I'm using this container which is having good height, nothing else than that. I don't want the measuring cylinder over there. I just want the good height over there. And I'm having these pieces which is Shahabad Farshi, and I have just crushed it into small pieces. Whenever the pieces are small, it automatically increases the area of contact, and that's why the rate of reaction increases. Now you can see what is written over here. Can anybody read this?
Sorry, it is not
Sulfuric acid
acid.
and hydrochloric acid. Hydrochloric.
It is
Sorry.
Hydrochloric acid.
Hydrochloric acid.
Hydrochloric acid. Hydrochloric acid, sir.
Hydrochloric acid.
अब सर ये हाइड्रोक्लोरिक एसिड हमको कहां पर मिलेगा? तो घर में जो संडास साफ करने
Sir, in our stomach.
की वो भी हाइड्रोक्लोरिक एसिड ही रहता है. One will have to use this carefully. The actual process is this, that I should transfer this to another container and I should use that container over there.
Sir, can you please stop sharing screen?
So you can see the effluences are going on. सर वो कार्बन डाइऑक्साइड उसमें होगा तो उड़ जाएगा ना सर? वो खोलो मत ना ऐसा. No, it won't, because it is heavier than air. So it will be adjusting itself over here only. Huge amount of carbon dioxide must have been evolved. I'm having this candle attached to this stick. Nothing special about it. A simple spoke which I have bent so that it will be easy for me to put it in this. It immediately extincts because it is filled completely with carbon dioxide.
Sir, we can't see it.
So we couldn't see it, sir.
Okay.
Yes, sir.
So you can just adjust the camera a bit up.
Now it's okay.
Yes, sir.
Yes.
How rapidly? Just see. मॅडम मला पाणी पाहिजे होतं साधं. Even I can use my saliva. This is blue litmus. Which is aqueous, and you can see the change in color immediately.
Yeah.
Yes, sir.
Yes, sir.
This is due to
Yes,
carbolic
sir.
acid. Wonderful. No need. I have done it. ते जिभेच्या यानेच ओलं केलं त्याला थोडंसं. नाही.
Sir, now will that carbon dioxide remain there only, or it will get exhausted? Means it will get outside that flask.
Why it will get outside? Who will make?
Sir, after some time.
Why? It is heavier than air, so it will remain over there only. Just see. It's still there. It is filled up to this level.
बाहर ही नहीं जा रहा है.
And I can even pour carbon dioxide from one container to another. एखादा ग्लास द्या रिकामा मला. हो. That also we can see.
सर इसके बाहर क्यों नहीं जा रहा है?
हाँ? एक मिनट. Right now this is easily possible. It is still burning. I hope you are able to see.
Yes,
sir.
Yes, sir.
Now I will try to pour carbon dioxide in this. Sir, what you are pouring? Carbon dioxide. Sir, we are not able to see it. It's colorless. Let me hope that my speaking have not disturbed it. हो गया.
हाँ सर.
Sir, it is like water.
Yeah, it is like water, but water is always visible beta, so we can get a feel of it. Here, though I was knowing the science, I was a little bit worried whether it will work or not. It works wonderfully. So great. Take garam hai. So we have seen the physical properties by our own eyes. Carbon dioxide is colorless. Yes, it is colorless. Now, whenever you will do the experiment, you can see that it is having very faint odor. If your nose is really sensitive, you can feel that carbon dioxide is more over here. Very faint odor. It opposes burning process, hence used as a fire extinguisher. We have seen that particular very clearly. It turns moist blue litmus into red. means aqueous carbon dioxide which becomes carbolic acid is acidic in nature. अब ये ठंडा कोल्ड ड्रिंक के जैसा हो गया. कार्बोलिक एसिड हैज टू बी एसिडिक इन नेचर इफ इट इज एसिड. एनीवे, that is the way how it is said. It turns lime water milky as white precipitate of calcium carbonate is formed. All these experiments we have seen except odor. And when HCl reacts with calcium carbonate, we can get the CO2 for experimental purposes, which can be transferred from one container to another container like a liquid because it is heavier than water, heavier than air, sorry. Now, when we see these experiments throughout our life, we never forget these properties.
सर ये कार्बन सिर्फ HCl के साथ अगर कार्बोनेट कैल्शियम के साथ रिएक्ट करता है तो ही ट्रांसफर होता है कि कोई और के भी रिएक्शन किया तो भी ट्रांसफर कर सकते हैं कंटिन्यूस?
क्या बेटा?
ये HCl के साथ अगर कैल्शियम कार्बोनेट रिएक्ट कर रहा है तो हम लोग उसको ट्रांसफर कर सकते हैं कंटेनर में, तो किसी और के साथ अगर कार्बन डाइऑक्साइड रिलीज हो रही है तो उसको भी ट्रांसफर कर सकते हैं?
बिल्कुल कर सकते.
सर और वो ज्यादा इसमें ज्यादा मात्रा में रही तो उसकी स्मेल भी ज्यादा आती है?
नहीं.
कि नहीं आएगी?
नहीं.
सर लेकिन कंबक्शन के टाइम पे तो स्मेल आती है.
No, that particular is not of carbon dioxide. वो जलने की जो बास है वो अलग है. The odor of carbon dioxide is different, and I won't be able to explain it in words. That you will have to experience.
सर बट जलने के बाद उसमें सब कार्बन डाइऑक्साइड रहता है ना?
नहीं ना, केवल कार्बन डाइऑक्साइड कहाँ रहता है?
सर बट मैक्सिमम तो रहता है ना?
तो मैक्सिमम रहने के लिए फिर तुम्हारे पास में प्योर कोल चाहिए.
Excuse me, sir.
जलने के बाद में जो रहेगा, that particular will be pure carbon dioxide.
Excuse me, sir.
Yes, please.
So the experiment that you conducted now, can you please tell why was the candle flame not burning? Because I was disconnected for a while.
It was not burning because carbon dioxide is heavier than water, heavier than air, and it surrounds the flame. Flame needs oxygen. Oxygen cannot get into it. Air cannot get into it. Air is having lesser density than carbon dioxide. And that's why it extinguishes.
Okay, sir. Thank you.
Right. Assemble the apparatus as shown in the figure. Whatever I did, it is done in this experiment.
सर ये रिएक्शन को क्या बोलते हैं? नेम व्हाट क्या है?
Reaction of HCl with calcium carbonate.
सर वो कंबक्शन वगैरह जैसा कोई नाम नहीं है क्या उसको? स्पेशल
नहीं. This is just a chemical reaction. Thistle funnel is the one which is having such particular type of thing. What we have seen right now is in this Thistle funnel, the HCl was added. Please look at the figure also. Some small animation has been introduced. You can see calcium carbonate over here. Now it has said that the end of the funnel dips in acid. Why it is said? What happens if this particular Thistle funnel is little bit up and this end is above the acid? What's wrong in it?
Sir, it will start
Sir,
splashing.
CO2 will come out.
what will come out?
CO2, sir.
CO2 will not be collected only over here. It will also be going out from here. So we will be wasting the product which we are creating. तो कंजूस बनो, बेमतलब में के मोबाइल पर के मैसेज पढ़ते बैठोगे तो अच्छे स्टूडेंट नहीं कहलाओगे। वक्त को ठीक तरह से यूज करो, जैसे यहां पर CO2 को ठीक तरह से यूज किया जा रहा है। So CO2 is formed as a result of the reaction between calcium carbonate and HCl. Collect this gas in 4 to 5 gas jars so that you can do the experiments with it. The reaction is like this. CaCO3, it's a solid in state. Twice HCl is a liquid. CaCl2 is again solid. H2O is liquid and CO2 is gaseous. Gaseous is indicated by such symbol. So this figure is available in the book along with the experiment.
Sir, please show me a previous slide.
सर वो पिस्टन को बंद भी कर दिया तो भी वो कार्बन बाहर निकल सकता है क्या? वो जहाँ से डाइल्यूट हाइड्रोक्लोरिक एसिड डाल रहे हैं।
हाँ, वहां से क्या करना?
उसको अगर बंद कर दिया ऊपर से तो भी कार्बन डाइऑक्साइड निकल सकता है क्या बाहर?
नहीं, फिर नहीं निकल सकता, बराबर है
सर। फिर वो ऊपर भी रहा तो फर्क नहीं गिरेगा ना कि
हाँ, मगर उसको बंद करना पड़ेगा फिर।
ओके सर।
हाँ, जैसा हमने किया वही किया हमने, उससे वेस्ट नहीं हुआ कार्बन डाइऑक्साइड, मगर जब ऊपर तक आया था इसका मतलब कुछ थोड़ा सा ओज आउट हो ही गया, उसमें से काफी ज्यादा निकला।
Complete, sir.
Right. Now this is just to be noted, nothing else. Sodium carbonate is formed when carbon dioxide is passed through an aqueous solution of sodium hydroxide. सोडियम कार्बोनेट का मीनिंग हमारे धोने के लिए जो सोडा यूज करते हैं, वॉशिंग सोडा। So the carbon dioxide is passed through aqueous solution of sodium hydroxide. Sodium hydroxide is having its name as NaOH. NaOH reacts with carbon dioxide. It gives Na2CO3. This is what is washing soda, along with water. You can verify the number of molecules over here must be same as number of molecules over here. When molecules will be same means obviously mass will be same.
सर ये बाहर का टू टोटल के लिए है ना, यहाँ पे Na के बाहर जो है लेफ्ट साइड में
टोटल की Na दो मॉलिक्यूल्स लिए मैंने NaOH के।
अच्छा हाँ सर।
Yes, it is called as for balancing the equation. मैंने केवल NaOH लिखा यहाँ पर, तो फिर वो Na2CO3 नहीं होगा।
सर ये एक्वेस सॉल्यूशन का मीनिंग क्या है?
Aqueous solution means it is containing this NaOH is always aqueous. It is very much hydrophilic. If you keep NaOH like this, it absorbs the water. जैसे सर्दी के दिनों में या rainy days में salt attracts the moisture. So in the same way, the sodium hydroxide is having great affinity towards water. Here it is aqueous solution, means the sodium hydroxide added with water. But the reaction happens in sodium hydroxide and carbon dioxide. Similarly, sodium bicarbonate is formed on passing CO2 through an aqueous solution of sodium carbonate. यानी यहाँ का जो प्रोडक्ट है वो प्रोडक्ट लेकर उसके साथ में अगर कार्बन डाइऑक्साइड को रिएक्ट करने के लिए बोला, then what we get is sodium bicarbonate. This indicates baking soda, which is many a times added in fermentation process, like while doing idli, dosa, or even cake, baking soda is added. Reaction is something like this: Na2CO3, H2O, aqueous solution, plus CO2. It gives NaHCO3, that is what is sodium bicarbonate. This is the equation of baking soda, and this particular is washing soda.
सर अभी इस लास्ट के इक्वेशन के साथ अगर CO2 को रिएक्ट किया तो क्या फॉर्मूला?
वो रिएक्ट तो होना चाहिए ना, ऐसा अपन मनगढ़ंत कहानियां नहीं बना सकते।
ओके सर।
बेकिंग सोडा लो, उसके साथ में CO2 को रिएक्ट करो, रिएक्शन होगी तो वो उसको अपन बोल सकते हैं। रिएक्शन ही नहीं होगी तो फिर क्या बोलेंगे? Chemistry is not possible by just having the piece of paper and pen. You need the chemicals.
Sir, for the exam on Saturday, which syllabus for 8th grade is coming?
Which is concerned with our syllabus, not the.
Okay.
So some questions related to structure of atom in 8th standard will be there. Then in 8th standard, some solid, liquid, that concept is there.
Okay, sir.
Something like that. Actually, you should not prepare for this particular competitive exam course. It should test your ability. And today some exams notification has come. We have posted that particular. If you are interested, and you should be interested, try to appear for those exams. Everyone done?
Yes, sir.
Yes, sir.
Yes, sir.
So uses of carbon dioxide. Obviously, it is used to make aerated drinks, very popular among youth as well as old people. Coke and Dew and this and that, lot many. Thumbs up. The plants use carbon dioxide in air for photosynthesis. During this process, they prepare their food and energy, and the byproduct is oxygen. But the photosynthesis is always having two parts. One is during daytime and other is during dark time. During daytime only, the oxygen is prepared. At night time, oxygen cannot be prepared during photosynthesis. And mind well, every plant, right from banyan tree to grass, is having breathing. So it inhales oxygen and gives carbon dioxide. That is always going on. And that's why if the tree is very big, it is not advised to sleep below the tree during night time. Because during night time, due to its respiration, the carbon dioxide will be prepared and it will be trickling down because it is having more density than air. And there will be a layer of carbon dioxide below the big tree. If I sleep over there, unknowingly, I may lose my life because I won't be able to breathe properly as the flame is not able to burn. I won't be getting oxygen. CO2 is obtained by chemical reaction or kept under pressure, is used in fire extinguisher. So either it is kept under pressure or it is chemical reaction, instant chemical reaction, and that CO2 can be used as a fire extinguisher. Liquefied carbon dioxide is used to remove caffeine from coffee. Caffeine is a toxic substance, and from coffee it is removed by using liquefied carbon dioxide. It reacts with caffeine. Liquid carbon dioxide is also used as a solvent in several many eco-friendly dry cleaning. Generally in huge factories, whenever the dry cleaning is done, at that time the solvent is liquid carbon dioxide. Many a times it is petrol, if you might be knowing. So instead of that, liquid carbon dioxide is used. There is solid carbon dioxide also. It is used in a cold storage and also to keep milk and milk products and frozen substances cool during transport, even the COVID vaccines. They are kept in solid carbon dioxide, and I hope that all of you must be knowing that it is also called as dry ice. And whenever we say that in outer planets the ice is there, ice means not the solid H2O. Ice means dry ice. Well, because of its way of appearance, it is also used for getting special effects of mist in dramas and movies. This is how the dry ice looks like. Have you completed the writing part?
No, sir.
No, sir.
I will wait for some time.
सर एक्सक्यूज मी.
Yes.
सर वो बुक में लिखा था कि कोई कोई प्लांट्स रात में भी ऑक्सीजन देते, वो गलत है क्या? वो पीपल वगैरह जैसे लिखा था.
नहीं नहीं, ऐसा कुछ भी नहीं होता.
गलत है क्या सर वो?
हाँ, फोटोसिंथेसिस कहाँ होता है रात को?
ओके सर.
हाँ, वो कुछ तो भी दिमाग में होली ट्रीज वगैरह ऐसा रहता है और उस कारण उसके साथ में जोड़ देते हैं.
सर वो टीचर्स भी वो बोलते कि वो रात में ऑक्सीजन छोड़ता है.
तुलस भी वैसा है, फिर सब्जा भी वैसा है, सब ढकोसले है.
ओके सर, थैंक यू सर.
हो गया रे? This is
Yes, sir.
how the particular dry ice looks like. और ये वहां से निकलने वाले फ्यूम्स. ये GIF इमेज है, उस कारण वही रिपीट हो रहा है वहां पर. इट्स नॉट अ वीडियो. फायर एक्सटिंग्विशर कैसा रहता है? अब ये बाबा आनंद के जमाने का फायर एक्सटिंग्विशर एक्सप्लेन कर रहा हूं मैं. Nowadays it is totally different. The fire extinguisher contains sodium bicarbonate powder, and there is also dilute sulfuric acid which is placed in a glass capsule. Whenever I press the handle, at that time capsule breaks on pressing the knob, and the sulfuric acid comes in contact with the sodium bicarbonate. So instead of HCl, we are using sulfuric acid over there. And it reacts chemically to release carbon dioxide which comes out. This is the reaction. Sodium bicarbonate, we are already familiar. It is baking soda. The two molecules of baking soda will react with H2SO4 acid. It will form Na2SO4, then water, and two molecules of carbon dioxide. So it generates more carbon dioxide. That's why it is used over here. The assembly obviously looks like this. You are familiar to this. But if I try to see within this assembly, at that time, it appears to me in this way. So this is the handle, this is safety pin. Whenever I remove this, I will be able to press the handle. Whenever I press the handle, it is connected with this piston, and the piston will break this glass tube which contains sulfuric acid. It's a can of sulfuric acid, it breaks and the sulfuric acid comes out. Here is sodium carbonate or sodium bicarbonate. Over here it is written as sodium carbonate solution. You can have sodium bicarbonate powder. So the carbon dioxide gas is released heavily and it comes out from this nozzle. So this is the way how it works. The figure is in your book, not this one. This is more explanatory, which I think. So I introduce this.
Sir, but there are different kinds of fire extinguishers, sir. Do they have
Nowadays the process has been completely changed.
Oh, okay.
This is old one, Baba Adam के जमाने का, इसीलिए मैंने बोला पहले. Now it is type A, type B, type C.
सर वो साइफन ट्यूब तो बहुत नीचे है, उसमें से निकलता कैसे होगा?
क्या
ऊपर
नीचे है?
साइफन ट्यूब जो उसमें दिखा रहा है वो उसका पॉइंट तो बहुत नीचे है.
हाँ तो वहीं से निकलेगा ना.
सर वो ऊपर रहा तो जल्दी नहीं निकलेगा क्या? खाली एम्प्टी स्पेस में रहा तो?
नहीं, I'm not getting you. The carbon dioxide will be created everywhere, so it has to be taken out. These are the ways for that. There are different heights also.
सर वो स्मॉल भी रहा तो फर्क नहीं गिरेगा?
हाँ, वो स्मॉल ही रहता है.
So then what do they use in the fire extinguisher these days?
It is inert gases are there. Then the dry ice is there. The powder of carbon dioxide is there. Lot many different things are there.
Sir, if we compress the fire extinguisher gas, so it can convert into dry ice also, no?
Yes.
सर इसमें प्रोड्यूस हुआ H2O यूजफुल रह सकता है क्या?
हाँ,
इसमें जो H2O जनरेट हो रहा है उसको यूजफुल कर सकते हैं क्या? यूज की नहीं?
H2O
ये इधर लिखा ना रिएक्शंस में.
क्या यूज करेंगे उसका? वो तो इसके साथ में मिला हुआ रहेगा, Na2CSO4 के साथ में.
सर वो सेपरेट नहीं कर सकते?
सेपरेट कर सकते, मगर वो सेपरेट करने के लिए जितना पैसा लगेगा उसके कम पैसे में अपने को बिस्लरी बॉटल आएगी.
ओके सर.
Now methane, molecular formula CH4, which we have seen at the very beginning. Molecular mass will be 1 carbon, 4 hydrogen, that's why 16. Melting point of methane is minus 182.5 degrees centigrade and boiling point of methane is minus 161.5 degrees centigrade. Methane is in gaseous state at room temperature, obviously, because room temperature is not negative. It is a colorless gas. We won't be able to see the methane color. The density of liquid methane is less than that of water. And the methane is sparingly soluble in water. Very less amount, extremely less. So I hope that you remember this is how methane look like. But it is highly soluble in organic solvents like gasoline, ether, alcohol. Alcohol is one of the very good organic solvent. Methane gas was discovered by an Italian scientist, Alessandro Volta. This is the same Volta who has designed Volta cell, who was appreciated by Napoleon Bonaparte. He was made a corporator by him. And he was the first person who identified that chemical reaction can generate electricity. So in his memory, we even today call potential difference we measure in volt, in the memory of Volta. It was somewhere in between the years 76 to 78, 1776 to 1778, 18th century, when he was studying the gases which are found in the marshy land. So in marshy lands, methane is generated, and he identified and studied that gas. I always feel that we should know the faces at least of this great scientist and names of the Indian scientists also. So the Volta look like this. If someone is still writing, they can continue. Okay.
सर ये मीथेन ऑक्सीजन के साथ रिएक्ट करके हार्मफुल सब्सटेंस बन जाता है ना?
या ऑक्सीजन के साथ रिएक्ट करना है, नहीं वो जलना हो गया बेटा.
सर वो
When it burns, it will create carbon dioxide, carbon monoxide if it is partially burning. Otherwise, it is just going to create carbon dioxide and water. Why poisonous?
सर वो पढ़ा है एक जगह, लिखा था कि पॉइजन.
अरे मगर रिएक्शन तो तुझे पता है ना. CH4 अगर ऑक्सीजन के साथ में रिएक्ट हो रहा है तो क्या क्रिएट करेगा वो? H2O और CO2. दूसरा क्या कर सकता बेचारा? हाँ नहीं सर, मगर पॉइजनस होना ही है मुझे, तो फिर उसको ठीक तरह से जलने मत दो, पार्शियली जलाओ जिससे कार्बन मोनोऑक्साइड बनेगा. यस, कार्बन मोनोऑक्साइड इज डेफिनेटली पॉइजनस फॉर ह्यूमन बीइंग. It destroys RBC. So you die due to the particular problem of brain hemorrhage. Brain don't get blood properly, actually oxygen properly. Chemical properties. Methane is highly inflammable. It burns by reacting with oxygen to give the bluish flame. the flame which we see in our usual gas. In this reaction, it is having very calorific value. This is known as calorific value. So it is 213 kilocalorie per mole. 1 mole when it burns, it gives 213 kilocalorie. So quite high, which is equivalent to kerosene. So many a times methane is also used in rockets. Methane and chlorine gets react with each other at the temperature of 250 to 400, but it needs ultraviolet light. It forms mainly methyl chloride. Methyl chloride is IUPAC name. It is also commonly called as chloromethane.
सर यूज क्या है इसका?
This particular is used in industry. The process is called as chlorination of methane. It is catalyst. It is used in dyeing process. In industry, it is highly useful, particularly fiber industry, textile industry, I should say. It is also used in glass industry for giving the colors to the glass.
Sir, please show me a PSC.
सर ये मीथेन में जो H2O निकल गया उसको यूज कर सकते हैं क्या?
हाँ,
सर उसको किस फॉर्म में यूज कर सकते हैं करना है तो?
किस फॉर्म में यानी वो गैसियस स्टेट में रहेगा, जल रहा है, उसका कारण हीट रहेगी वहां पर. So obviously it will be a steam. So you need to condense it.
सर फिर वो वाटर मिल सकता है क्या?
बिल्कुल मिलेगा.
सर वो वाटर क्यों बोलते कंजर्व करने को, जब वाटर बना मिल जाता?
हाँ बनाओ ना, कोई दिक्कत नहीं. हर बार जब भी गैस जलाओगे बर्नर के आजू बाजू में कंडेंसर लगा के रखो. It will give you the condensed water. Definitely yes.
Done, sir.
Methane is from natural gas. It is used in industries such as fabric mills, paper mills, food processing industry, petrol purification. Being the smallest hydrocarbon, the proportion of carbon dioxide released in the combustion of methane is small. And that's why it is used as a domestic fuel. In our gas cylinder, methane is one of the major constituents. Methane is also used for production of organic compounds such as ethanol, methyl chloride, methylene chloride, and acetylene. These are all industrial demands. यश तुझा माइक चालू आहे. यश दाते. थँक यू. May I change?
Yes, sir.
Yes, sir.
Good. Now biogas plant. This is the last topic, which is source of methane. But this is not industrial source. This is used by the farmers or the person who is having biogas. Animal dung, dry leaves, wet garbage, etc. is decomposed by anaerobic microbes. Those microorganisms which don't need oxygen for breathing. So in biogas plant, they decompose these things. This produces methane gas, which is also called as biogas. Biogas is a very cheap fuel which meets the demand of the cooking gas. It is also used as a production of electricity. Biogas contains about 55 to 60% of methane and the rest is carbon dioxide. So the flame of biogas is not completely blue. It is blue and many a times if the carbon dioxide percentage is more, it turns yellowish. Biogas is a fuel which is convenient to use, and in addition to this, a very good manure is also produced, which can be used for the fields, for growing the plants. Yes, Aditya?
Sir, blue flame meaning it's combusting completely, right?
Yeah, and it is methane.
Yeah.
Basically, blue flame is due to the hydrogen, burning of hydrogen.
Okay, sir.
This is the way how the particular thing is. And as the gas increases, at that time, this dome comes up in this way. So due to the weight of the dome, the air, which is actually methane and carbon dioxide, is compressed. And that particular is giving the gas under pressure. This part of the biogas plant is called as digester. And here the dung, animal dung, dry leaves, wet garbage is added. And this sludge is actually a wonderful manure. It increases the quality of the field to a very large extent. The microbes act on a biodegradable complex organic compound and they produce organic acid. The methanogenic bacteria means the bacteria which are going to produce methane. They are called as methanogenic bacteria. They act on organic acid and they produce methane gas. This is how the process is. This is organic acid. This is general formula of organic acid, COOH. And here you can have anything, C2H5, CH3, anything over here. So
this digester में गैस का सिस्टम नहीं समझ
this slurry comes over here. The bacteria converts it into gas. The gas obviously moves up and lifts the tank up. Over here, the slurry is collected.
सर वो स्लज नीचे रहेगा ना जमा, ऊपर कैसे जाएगा उसमें?
क्या?
वो स्लज जो है वो तो भारी रहेगा, मतलब वेट रहेगा तो नीचे रहेगा ना, ऊपर कैसे जाएगा वहां पे?
इसकी क्वांटिटी जैसे बढ़ेगी तो ये तो ऊपर ही जाएगा ना। ये यहां पर है इसका ओपनिंग।
सर ये सिरिंज जैसा है ना?
हाँ
सिरिंज जैसा है ना?
हाँ, म्हणजे हे पिस्टन जे आहे ते ना. येस
हाँ.
येस, इट इज लाइक अ सिरिंज but not airtight. There is a gap over here. It can move up and down.
सर फिर वो स्लज के एरिया से भी गैस एग्जिट कर सकता है क्या?
नहीं ना, वो लिक्विड इसमें से गैस नहीं जाएगा ना बाहर। गैस इन दिस एम्प्टी पार्ट।
सर फिर वहां से क्यों नहीं जाएगा?
Some bubbles may go. Some little part, definitely it will go. Even over here, the gas will be produced. Process won't end immediately, na?
Yes, sir.
Yes.
सर पिस्टन सिर्फ प्रेशर के लिए है क्या?
हाँ, piston is for pressure. This is very heavy.
उसमें बीच में पाइप रहती है क्या सर गैस निकलने के लिए?
ये क्या है ना यहाँ पर?
अच्छा।
Excuse me, sir.
Yes, beta.
Sir, one statement was given that liquefied carbon dioxide is used to remove caffeine from coffee.
Yeah.
So what exactly is that method?
Coffee seeds are treated with the liquid carbon dioxide. And during that reaction, the caffeine is absorbed by the liquid carbon dioxide.
Okay, sir.
So with this,